Good afternoon. My name's Rich. I'm with Alta Devices. We make solar cells. And that video was going to show you a little bit about our manufacturing process, but that's okay. It's on our website, so if you guys ever wanted to go take a look at it, it's just one click away. And what I can do is, at least with a couple of slides, show you a little bit about how we make what we make, and then I'll talk about what our application space is, because we're not a traditional solar cell company. We definitely go after a whole bunch of different applications that are non-traditional energy applications. So what makes us different is we use gallium arsenide instead of silicon, and we start with a wafer as our building block. So we take one of these wafers, and if you look at it on end, they're pretty thick and they're quite brittle and they're actually quite expensive. So gallium arsenide's always been a pretty expensive material to work with. So the whole point of our manufacturing process is to figure out a way to make the solar cell as cheap as possible, but still retaining all those awesome performance characteristics of gallium arsenide as a solar cell. So we did that by essentially creating a manufacturing flow which uses a process called MOCVD, which is metal organic chemical vapor deposition. All that means is we're laying down really thin layers of metal on top of a substrate, and we keep growing the stack vertically with different materials. So one of those materials is aluminum arsenide. The nice thing about the 3 5s on a periodic table is you can mix and match them. So instead of gallium, we turn the gallium off, we turn aluminum on, and we lay down a layer of aluminum arsenide. And then we turn the gallium back on, and we lay down another layer. This time it's gallium arsenide. And then we cover that with metal, we cover that with plastic, and now we have this sandwich of all these different layers that we've built up on top of this wafer. We take this stack and we stick it in a giant bath of hydrofluoric acid. It's like 2 stories tall, and we're putting hundreds of wafers in there at a time. The hydrofluoric acid is magical because it etches away the aluminum arsenide but leaves everything else alone. So what happens is that little yellow layer disappears, and it allows us to lift off everything that we grew above it from whatever was there below it. And so that allows us to reuse that wafer over and over and over again, because it just goes back to the beginning again. So we never consume that expensive piece of gallium arsenide in our manufacturing process. We only utilize that super thin 1 micron layer that we laid down above that aluminum arsenide layer. So at this point in the manufacturing process itself, you have something that looks like this. It's 4 inches square, it's copper on one side, gallium arsenide on the other. It's super thin, super flexible. It's not a solar cell yet because there's no front metal on it yet, but this is what comes off at this point in the process. And then we do the simple stuff, which is just basically etch and screen print some front metal onto the tile, and then we cut it up into individual squares. So this is what it looks like before it gets cut up, and then finally we end up with a solar cell, which looks like this. So this is our basic building block. Everything we do starts in this form factor, and it's 1 micron thick of gallium arsenide surrounded by metal and plastic and a little bit of front metal. So this is everything you need to do all the things that we do. So then we have a machine at the end of the process, which that video was going to show you, which is basically what we call our matrix tool, because it matrix these little individual building blocks into sheets of whatever size you need. So here's a large sheet that could be put on a wing of an airplane. We can make smaller sheets, whatever size and dimension is needed for the given application. And as you can see, it's really thin, super flexible, really lightweight.
Good afternoon, ladies and gentlemen. Please join us for the Warriors to the Workforce booth, number 261 at 2:30, for a presentation by David Muir, Senior Vice President, Easter Seals Veterans Staffing Network. The topic of the presentation will be professional networking. Again, in booth 261, Warriors to the Workforce, a presentation by David Muir from the Easter Seals Veterans Staffing Network. The topic will be professional networking at 2:30. Please join us.
Okay, so you may wonder, what good is all of this for? So I guess one more thing to talk about before I get into the application space is, how does this compare to other technologies? So I did have a couple slides on comparison with other solar cell properties. So you can see, kind of going left to right, along the top you see percentages. Those are efficiency percentages. So anywhere from 10 or less percent all the way up to ours, which are closer to 30%, is kind of the range of traditional sort of commercially available solar technologies out there. Before Alta existed, the ones on the left were the only way you can get something that's thin and flexible. They happens to be typically the low efficiency variety. And then as you get more and more efficient, you started working with silicon wafers, and they ended up being rigid and heavier. So what we wanted to do is solve that problem. And so another way to look at it is watts per square meter on one axis and watts per kilogram on another axis. And what you're trying to do is be up in that upper right-hand corner, which is where our solar cells live, because we provide both thin and high efficiency. And if you boil it down to a number, which all marketing guys love to do, you take the product of those two things and square root it, and you create this watts per square root of kilogram times meter squared, which is kind of the ultimate size, weight, and power metric for solar cells. And so you can see our number is significantly higher than anything else out there. And it's true, we are 3 to 4 times better, if not more, compared to other technologies for anything that requires size and weight, and you're trying to get the maximum amount of power. Okay, so what good is this for, really? So we look at the world in terms of batteries. We look for opportunities where battery life sucks and people want more of it. And so by putting solar cells onto those products, we can extend that battery life. And so that ranges from everything from an automotive application to a UAV application to a cell phone to an unattended ground sensor to a smoke detector to a Bluetooth beacon, et cetera, et cetera. And I'll step through a bunch of examples of real customer engagements that we have. Some of these are obviously very much military-centric, and some of these are very much not military-centric. So we tend to play quite a bit in the commercial sense, in the commercial world, in addition to a lot of the applications you might see at a show like this. So our probably most famous example that we talk about is the Puma. We did work with REF, who was just up here, and did a program with a solar-powered Puma. The results were fantastic. They got over 9 hours of flight time on a plane that typically flies 2 or 3 hours. Tremendous amount of value in being able to do that. And so there is interest in REF to sort of take the next step on that program. So that's something we need to close the loop on and understand what those next steps might be. But AV is definitely working very closely with us to make this a reality. And so there's a whole commercial world to the fixed wing UAV market. There's a lot of interest in agriculture, a lot of interest in border patrol, things like pipeline management, any kind of infrastructure management, search and rescue, fire safety, you name it. There's a million applications that people are talking about using UAVs for, and a lot of those will be small fixed wing platforms. And then there's a whole bunch of applications that what we call the high altitude, long endurance fixed wing UAV market. These puppies are the size of 737s. They fly for months at a time. They absolutely need solar cells because that's the only way they can recharge the batteries every day. So there's a pretty big emerging market here. It's mostly commercial. I think we're seeing some interest in the DoD side of things as well, but it's mostly to provide communication services to the people that don't have it today. So you may have heard companies like Facebook and Google and Airbus all talking about programs that will eventually enable this sort of thing. And so we're very interested and eager to be a part of that marketplace. And then there's always been talk of airships. There's lots of interesting ways to get goods and other things to places that you can't necessarily fly an airplane into or wouldn't necessarily want to fly an airplane into. So package delivery, medical services, those kinds of things. Airships might be an interesting way to do that. Certainly surveillance is another thing that's popular for these kinds of platforms. And solar is just an obvious choice to add a certain amount of power to these platforms. And then you get into all kinds of other unmanned systems, marine systems, buoys. You start to get into the RC world. So there's a lot of applications where if you could provide enough power and make these things autonomous longer, then it's all good and it's win-win for everybody. So then there's the next few markets I'll talk about. In this case, we're talking about remote power. So what if you could carry power with you into the middle of nowhere and be able to recharge your electronics that way? So for example, 60 watts of power from a 24-ounce charging mat is pretty compelling if you are carrying a bunch of other stuff with you and you need that power to sustain your life for a number of days. So we're engaged here as well with a number of customers to provide solutions that can do that. There's obviously a military need for that, but there's also an oil and gas industry and other industrial needs for power in austere locations. I love the camel, by the way. That's my favorite picture. And then we get into the consumer space. You got bags and backpacks and other types of ways to keep your devices charged all day long. And then why stop there? You might as well start putting solar onto the devices themselves. So we have a ton of interest in the wearable space now. A small little solar cell on a device like that and 30 minutes of sunlight a day, you never have to charge it ever again. So you eliminate the recharge cycle at the end of the day if you put just a little bit of solar onto these devices. So that's really compelling for being able to take this whole market to the next step. And this could be used for lots of things: keyboards, mice, remote controls, watches, all kinds of exercise computers and equipment. You get to now talking about indoor devices, things like smoke detectors, beacons, security devices, medical devices. There's a whole slew of things that are battery powered today, and it's either annoying that you have to go change the battery or they just don't last long enough. And so both of those things are pain points that we're trying to solve. And so we talked about pipeline management, other infrastructure. There's lots of different ways to put sensors along the way to keep the flow happy and know where problems might start to occur. Earlier today, we heard from someone talking about unattended ground sensors. Boy, wouldn't it be nice if they worked longer, or if you never had to worry about running out of power and they just kind of recharge themselves every day. So that's something that we are certainly interested in enabling. And then you get into the big markets, things like cell phones, tablets, laptops. A little bit of solar goes a long way on these types of devices. All kinds of communications equipment. There's ones that are specifically designed for police and fire and campers and outdoor people and construction workers, where they do need all-day battery life or multiple-day battery life to be useful. And then last but not least, you get into the whole transportation world where putting solar on roofs of cars. We're not that far away from seeing this as a very common thing to do. And there's government incentives that are going to be put in place to help incentivize manufacturers to do this. But it does provide useful benefits. Today, you already see small little solar panels on Priuses and Leafs and cars like that, where they produce a comfort feature where it just runs a fan or keeps the car cooler during the day. It won't be long where if you have enough power, you can start to provide meaningful range extension into these types of vehicles. And so why stop there? You have the whole transportation industry with trucking and buses. Everything's going electric, and everything's going to ultimately need more access to power off the grid. So these are all different places that we're looking at putting our technology onto, because it is so thin and lightweight, it doesn't really impact the vehicle itself. So it becomes a really good match for our form factor. Okay, so how big is this market? This sounds niche to me. So let's do some math. So let's just say sometime in the future there'll be 10,000 UAVs flying, which I don't think is that far-fetched. I think we're certainly gearing up for a world where there's a lot of unmanned airplanes out there. 100 million wearable devices is a number that I think we may have already crossed with the Apple Watch, but that's a number that people were throwing around as far as the future was concerned. Automobiles, we're very close to producing 100 million cars every year in the world. So that's a number that we're a few years away from. And 1 billion mobile devices is something that I believe we're already crossed today, and we're very close to producing 1 billion smart devices every year. And then the world of sensors, you know, a lot of experts are throwing around that trillion number for the Internet of Things and everything else that's ultimately going to be connected to the Internet. So if you take all of those things, and I know this is not how most marketeers calculate total available market, but if you were to literally cover every single one of these things with our solar material and do the appropriate math on how much you can fit on a car, how much you can fit on a plane, that translates into over 200 gigawatts of annual demand for something like this. So, you know, that's a huge number for us. You know, we're obviously not there yet in terms of production capacity, but we're working on it. You know, we have plans in place now to scale our factory to get to price points that will enable all these markets. So we're starting with markets that really need the power density, and we're working our way. As our price comes down, we start to go after more and more of these markets. And it won't be long, 5-6 years from now, that will be in the single-digit dollars per watt price point, which makes this very compelling for all those things that we just talked about. So our vision is to empower the unplugged world and put solar cells on everything. And anywhere you can see, they'll be covered with solar cells. So that's what Alta Devices is all about, and I'd be happy to take questions if anybody has any. And I have the mic. Catch.
Everybody knows everything about gallium arsenide. Okay. Okay.
You're mentioning solar. What about other types of light?
Yeah, it's a good point. You know, we have, in some of our literature, we talk about solar not just for sunlight anymore. So it is true that anywhere there's a photon, we can turn it into an electron. It turns out that our efficiency stays quite flat, even in very low light situations. The difference is, in this kind of lighting environment, it's about 1,000 times less power than sunlight, but we still convert around 30% of it into electrons. So we can work in any kind of light, and the rate stays the same, but ratio stays the same. It's just you get 3 orders of magnitude less power, so you're talking about, you know, microwatts versus watts in that case. But it's still enough to do a smoke detector or an alarm sensor or a motion detector or something else that you want to put inside a home or a factory or an office building.
You got a question? Okay, 2 questions.
You mentioned before about in the last slide, it was the price of the next year at some tens of dollars per watt. I was wondering, is it possible with these photovoltaics to concentrate light on them? Are they tested for, let's say, above 3,000 watts per square meter or something like that?
We've done quite a bit of work on concentrated light. The current design that we have today works well to about 10x concentration, so low X concentration. It is possible to design a different cell technology which does get you to higher levels of concentration, and that is a market that we're certainly paying attention to, but it's a little bit of a chicken and the egg. The market's not quite there yet until the technology exists, and the technology, you know, there's no point in making the technology because there's no market for it yet. So we'll see. As things evolve, that's very much something that we're going to be paying a lot of attention to.
I got two questions. One is for maintainment and sustainment. So let's say this thing gets dirty. How do you, if it's up in the air, how do you keep the, or what's the residue level that gets on it that you have to worry about where it's not effective?
Okay, let me do question number one first. So it's just like any other solar material. If the top sheet, whatever that happens to be, and there are different materials that we can work with, if it gets dirty and starts producing or starts prohibiting light to get through, you will get a power reduction. So just like the solar panels you put on top of your house, they recommend cleaning them off every once in a while to get back to that full level of power output. Now, there are materials that are more resistant to dirt and dust and things like that building up. So that's what we would be, working with you on to understand what is your application space. Where are you using this? Where's the UAV flying? How much dust are we talking about? Or how often do you have to clean it just to make sure that you're getting back to your full performance again?
And you may have mentioned it earlier. What's the life cycle on it? What's the sustainment piece? How long can we expect it to last?
Yeah, so these are single crystal gallium arsenide structures, which are really good from a long-term reliability standpoint. So we've done a bunch of tests, and for like an example of a rooftop application where you just stick it up there and leave it alone, we show that we can certainly survive 25 plus years of operation. You do lose a little bit per year. It's like something around 1% per year, but it's a pretty small amount of degradation. If you put it into other environments like a UAV or a soldier backpack, then it really all comes down to how much rough handling is it going through and what kind of material are you encapsulating it in. So those could affect your lifetimes differently from just sticking it out and leaving it alone for a long time. So it kind of depends.
Okay,
All
thank
right.
you, Rich.
Thanks, guys.
Rich